To most people, the world is a well-mapped globe, but to the geodesist, it looks like a jigsaw puzzle with many pieces still missing. Take Australia. Men have learned its approximate shape and size, but they are not quite sure how it fits into the picture. Exactly how far is Sydney from Hong Kong, or from Chicago? And Africa? Exactly what are its true dimensions, its precise position on the face of the earth? Should the coastline be here or here? For centuries, ground surveyors with various surveying instruments have been slowly fitting small parts into the puzzle. They have measured and mapped Europe, North America, and other inhabited land masses. But their line of sight is limited to about 30 miles by the curvature of the earth and terrain obstructions. They have determined the exact distance from Paris to Rome and from New York to Chicago. But until 1956, they could not tell you the exact distance from Paris to New York. Turner Air Force Base, Georgia, home of the only organization of its kind in the Air Force, the 1370th Photo Mapping Wing. Under the command of the Air Photographic and Charting Service, MATS, its mission is to contribute to the eventual completion of the gigantic geodetic puzzle. Here are some of its achievements. The North Atlantic tie, which link together the triangulation nets of Europe and North America. The Patrick tie in Florida. The photo mapping of Spain, Italy, Norway, Greece, and portions of many other countries. To accomplish the missions, the 1370th uses modern aerial techniques, precision visual mapping photography, electronic geodetic surveying called high-ran trilateration, and electronically controlled photography. Precision visual photography is used to produce detailed topographic maps and charts of extensive areas by the science of photogrammetry. Maintaining a constant altitude, the aircraft flies along a series of parallel lines laid out on existing maps or charts, taking pictures of the terrain. These photographs provide complete coverage of all natural and cultural details on the ground. High-ran trilateration is an intricate system of extending geodetic control by measuring the distance along the sides of a geometric figure in contrast to the conventional ground method where angles are measured and distances computed. High-ran is capable of single measurements of over 500 miles within first-order accuracy. Starting from a known location, ground stations are set up and the distances between them measured to bridge large expanses of unsurveyed land or water. The aircraft is equipped with electronic equipment which transmits ultra-high frequency pulses to the ground stations. These pulses trigger the ground station equipment, which transmits a reply pulse back to the aircraft. As these pulses travel at the speed of light, the time required for the signals to reach the ground stations and return is electronically measured while the aircraft is flown back and forth across an imaginary line between the ground stations. The airborne equipment automatically applies the formula of rate times time equals distance and records the distance to each station. To ensure accuracy, at least 6 crossings are made at each of 2 altitudes. The recorded raw distance data is corrected later for weather conditions along the electronic ray path and converted to distance along the surface of the Earth by a series of mathematic computations. When the distance between ground stations is established, another station is set up and measuring continues. In order to produce accurate maps from aerial photographs, the relative position and distance between features shown on the photographs must be known. Therefore, visual mapping photography must be combined with ground surveys, except when used for the cultural revision of existing maps. Ground surveys are expensive and extremely difficult in Arctic, desert, and jungle areas. Electronically controlled photography is a combination of precision visual mapping photography and the high-RAN techniques, providing most of the horizontal control needed for map compilation. High-RAN ground stations in known positions are used to direct the flight of the aircraft and to determine the relative ground position of each photograph. This permits accurate mapping of areas inaccessible to the ground surveyor. Measuring and photographing the globe is not a one-man job, but the result of the 6 squadrons that compose the 1370th. Here are the tools with which the wing works. The RC-130s of the 1375th Squadron and the RB-50s of the 1371st, which accomplish the primary missions of high-RAN and aerial photography. And here work the men who must maintain and keep the aircraft flying. The safety of the flight crews largely depends on the skill of these technicians. This squadron, the 1374th M&C, is responsible for maintenance of all air and ground high-RAN equipment, aircraft navigation and radio equipment, and aerial cameras and accessories. Here is a precision automatic photogrammetric intervalometer, one of the devices used to obtain precise overlap between individual photographs. And the Airborne Profile Recorder, or APR, which determines the elevation of terrain features. These are only a few of the delicate and sensitive instruments that the squadron must keep in working order. But the 1374th has other jobs also. The operation of a communication net for each project area, and a military-affiliated radio system station at Turner Air Force Base. But perhaps most important of all, it installs, operates, and maintains the ground stations. Since it was organized, the 1374th has overcome almost insurmountable obstacles. During the North Atlantic tie, high-RAN ground stations had to be established on Greenland's ice cap. Ski-equipped C-47s flew in supplies, equipment, and personnel. Because this area of the ice cap was 10,000 feet above sea level, JATO equipment had to be used for takeoff. Large blocks of snow had to be cut to reinforce shelters against a wind that sometimes roared by at 70 miles an hour. The problem of installing high-RAN stations in one of the most inaccessible areas of the world was solved by using a Norwegian and a Danish icebreaker, each carrying an H-19 helicopter. Despite the handicaps, the project was completed in August 1956 on schedule. When no ground site was available during another project, they built a Texas tower many miles offshore and moved their instruments by boat. On another occasion, they established a station on a rocky pinnacle in the tropics. The high-RAN crew lived aboard ship, commuting daily by helicopter to their lofty perch. Meantime, as the day-by-day work of the command goes on, this squadron keeps supplies ready to go into the field. Almost every item needed to keep an aerial survey team working effectively is here, ready to go to a project area. Aircraft parts and equipment, supplies and parts for the globally deployed ground stations. Each item in the mission kit is cataloged and recorded. Wherever the 1370th sets up for business, the medical men are with the unit. Highly competent personnel, under supervision of the flight surgeon, are assigned to the new areas even before the others arrive. As members of the reconnaissance team and part of the aerial survey teams, the medics will inspect the water supply and exact rigid supervision over foods purchased locally. They will combat fevers and poisons indigenous to the new operational areas. Maintenance supply mission kits have their counterparts in medical mission kits. This is a disaster kit, packed and ready to be airdropped into emergency areas. They wage their own particular kind of war to preserve and improve the already excellent record of the medics of the 1370th. Project requests may originate when a foreign nation wants remote areas mapped to develop natural resources. Once the State Department and Department of Defense clear a project and USAF routes it through MATS and APCS to the wing, the 1373rd Squadron goes into action. Existing maps have to be studied. How best can the mission be accomplished? Is visual photography the only requirement? Or must HIRAN be used to position ground stations for controlled photography? What airstrips are available? Has any part of the area been surveyed previously by ground methods? From this map reconnaissance, they design a preliminary trilateration net. Ground station sites are selected on a basis of operational, geodetic, and electronic feasibility. They estimate line lengths and predict the optimum flight altitude for each line. Meanwhile, command staff personnel from APCS and the 1370th visit the area to discuss requirements and consummate an agreement with local civilian and military authorities. They determine if the nearest U.S. military base can provide the needed support or if civilian or foreign military facilities must be utilized. The command reconnaissance is followed by a field reconnaissance party consisting of specialists from the wing. They work out operational, support, and logistics details with their counterparts in the area. They locate any existing ground control positions which have to be reoccupied and check other proposed ground station sites to determine if they are suitable. Aerial survey teams are operating in many parts of the world, each unit in its own phase of mission completion, either being activated or in full operation, or being wrapped up and moved to the next site. They seek advice on cultural customs. Indians like these may be seeing Americans for the first time. With a ground site located in such a village, it is well to know how to get along with them. The mission, as well as lives, may depend on it. They have to find out what housing is available on the local economy for administrative offices, maintenance operations, and for living quarters. Can the host nation supply aviation fuel, oil, and lubricants on a reimbursable basis? Are aircraft servicing facilities available? How about weather data for high-ran or photographic flights and many other items? On the basis of information gathered during the reconnaissance and their own research of available geodetic data, geodesists of the 1373rd designed the final trilateration net. When all planning is completed, an operation plan is formulated and published by Headquarters APCS. The preparations accomplished, the aerial survey teams, or ASTs, take over. The workhorses of the 1370th, the ASTs, are composed of specialists from all 6 squadrons of the wing. When they bid goodbye to their families, they know they may not see them again for as long as 6 months. Almost 2,000 miles from home, soon they are operating as a self-contained unit, as complete as if they were back at Turner. The team headquarters is established. Ground station operators are at their post. Missions are assigned. Equipment maintenance is going on. Communications have been established with ground sites. Most needed parts are on hand and can be found on a moment's notice. Aircraft are being kept in flying condition. For aerial survey teams, work starts early. If the mission is either electronically controlled photography such as this or visual photography, work goes on 7 days a week during periods of good weather. Whether accomplished by a long-range, high-altitude RB-50 or this jet-powered RC-130, a mission demands the greatest teamwork among members of the crew. Inside this aircraft is more than $1 million worth of sensitive equipment. Mapping cameras in gyro-stabilized mounts have been previously flown over a test area to assure their precision. A device called a straight line indicator is controlled by signals from the ground stations and shows the pilot which way and how far to turn to keep his aircraft on a straight course over the ground. An air profile recorder that charts the pressure, altitude, and height above the terrain being photographed, and many other pieces of expensive equipment. But these modern devices and the best teamwork can be stopped by the elements. Those clouds, for instance, will prevent photography. Only high-ran electronic geodetic surveying can be done during this type of weather. The accuracy of a high-ran mission is checked daily in the field. If all measurements of a line do not fall within close tolerances, the mission will be reflown. Most ASTs have their own photo processing and evaluation sections. While the primary mission is carried out daily, crewmen at isolated high-ran ground stations must be supported. At sites where runways have been built, the old reliable Goonie bird transports the supplies. Helicopters perform this service to the most inaccessible ones, bringing in food, replacement parts, mail, even magazines. The flights can be hazardous. If forced to land because of engine trouble, the chopper might disappear forever in the impenetrable jungle. This visit is a highlight for the ground crewmen. Except for radio, this is their only contact with the outside world. These isolated men are a vital part of the mission. During every high-ran or controlled photography flight flown in their area, they are always on the job. Recreation is limited. After a while, cards can get pretty tiring. To ensure proper support and operation, an inspection team arrives along with personnel replacements. Helicopter pilots who will shuttle supplies, laboratory technicians, ground station operators and maintenance men. Meantime, as the survey aircraft fly back and forth across the project area, a constant flow of reports and data goes back to Turner. Data is reduced by two-man teams who check and cross-check to eliminate chances of mathematical error. High-ran data recording cameras furnish film of instruments. When computations are checked for inaccuracies, mission distances are consolidated on a preliminary data sheet. When data is fed into this electronic computer, it will give the geodetic distances of all unknown ground stations from each other, making more than 40 mathematical computations almost instantly. While the high-ran data is being reduced, a similar process is going on in the photographic laboratory. Modern equipment is used to develop and print the aerial film. Continuous processing machines and this logitronic printer with automatic exposure compensation speed the production of high-quality prints and duplicate negatives. Here, pictures are checked to ensure acceptable coverage of the entire area photographed. Great care must be taken to verify that each photograph overlaps the one before and after between 53 and 60% and side-laps the adjacent strips not less than 10%. As with high-ran data, high standards are imperative. Insufficient or excessive overlap, poor negative quality or clouds, and a photo mission must be reflown. A standard indexing system records the coordinates of every fifth print. This record is filed with the Department of Defense Central Film and Print Library in Washington. The photographs are forwarded to the Map Compilation Agency and duplicates to the participating nation. The rest is up to the cartographers. From the measurements and photographs taken by aerial survey teams, they can make maps that will contribute to the welfare of mankind. From them, boundary commissions may resolve age-old border disputes. Engineers will be able to determine the proper route for highways, railroads, and plan water conservation projects. This is the aim and meaning of the mission of the 1370th Photo Mapping Wing.